Hello, everyone, and welcome to part 2 of the Silica and COVID-19 Protection webinar series. My name is Paula Hyman from the Ohio LTAP Center. Same as yesterday, before we begin, just want to make sure that everyone is still familiar with the questions box from yesterday. Just type a hello, good morning, whatever you want to type in there this morning, just make sure you know where it's located. That's how you're going to ask questions throughout the presentation. Periodically, Robinson will stop and ask for those questions, and he'll respond to those. Just a couple of other little housekeeping items. There will be a post-test and evaluation sent out to you via email, along with as long as the recording today is successful, you'll get the YouTube links to session 1 and session 2 of today's training. There are handouts in the handout section. You will see 5 handouts there, and those are going to be used for today's course. If you, for some reason, are unable to download the handouts, put your email address in the questions box and I will email it to you. Following the presentation today, again, just remember, look for those emails with the post-training survey and the test. We're going to do attendance verification for both days and send those out to you. With that, I'll pass things off to Mr. Robinson Vasquez, Business Business Developer and Training Manager with the American Road and Transportation Builders Association. Robinson?
Thank you so much, Paula, and welcome everybody to our second day of Silica protection training. As promised, I want to share with you this video. It's going to help us to summarize what we learned yesterday, and also help us to understand what was the evolution of the Silica standard. So let me start with this section of some people sharing their experience with Silica and
when I was just 13 years old, my father died of silicosis. The disease took about 5 years to kill him. Not only was it incredibly difficult, slow, and painful for him, but we had to watch it.
When I get exposed to dust now, and not just silica dust, any dust, it feels like I have a plastic bag around my head and someone's trying to pull it shut on me.
The doctor there told me that I should probably seriously consider changing my careers and seeing some specialists. That wasn't good news for me because this is my job. It's what I want to do, and it's all that I know.
Obviously, I spent a lot of time on oxygen all night long, and most times during the day.
If I known it was hurting me, or killing me, shoot, I'd have done things a lot different. I had no idea.
The history of lung disease among workers caused by exposure to silica is long and storied. About 2 million construction workers in the U.S. have had occupational exposure to crystalline silica dust. 59,000 of them will develop silicosis and other lung diseases during their lifetime. We've known for decades about how to prevent silica-related diseases. It's not until now that the solutions are mandated by law. Silica is one of the most common minerals on the planet. It's in the sand on our beaches and the quartz of our mountains and land masses. Silica is not dangerous to humans in and of itself. The problems start when we work to manipulate it for our own ends. And that's exactly what happens in construction. When materials that contain silica are disturbed, they generate small particles that can get into your lungs. And once they go in, they don't come out. On a construction site, we find silica in many materials. Here are some of the tasks that disturb silica and make it dangerous for workers. Bricklayers, cement masons, and roofers routinely work with silica materials. Operating engineers and laborers may work with silica materials when moving earth or doing demolition. If you do occasional cutting or drilling as an electrician, sheet metal worker, plumber, or pipe fitter, you may be impacted. And if your work puts you in a dusty area, you need to be aware of your surroundings. Silica is not a recently created hazard. It was first discovered by Hippocrates in about 400 BC. 4 centuries later, Pliny the Elder described miners who used forms of respiratory protection. In 1700, Dr. Bernardino Ramazzini identified evidence of silicosis in stonecutters. And in 1860, two English physicians, Peacock and Greenhow, conducted an autopsy of a mason and found a hard, gritty material in his lungs, which they called sand. In the US, in 1917, Dr. Alice Hamilton made the connection between the dust that Vermont granite cutters were inhaling and the resulting fatal illnesses. By the 1930s, those workers had successfully bargained for the installation of ventilation equipment in their worksheds. In 1931, the nation's worst industrial disaster took place during the building of a hydroelectric project in West Virginia. 1,500 mostly African-American workers who came north to find work ended up dying in the Hawk's Nest tunnel disaster.
They were ordered to drill through that mountain, and that mountain was made entirely of silica. And they had no meaningful protection at all. And it turned out, by the way, that the employer knew how dangerous it was, because when the engineers and the company representatives went there, they wore masks. So they knew it, but they didn't care about their workers.
476 workers died almost immediately. Many were buried in trenches in a nearby field with just corn stalks for markers. Another 1,500 contracted the disease within 2 years.
I lost 3 sons from working in the town of Silicosis. One is 18, 123, and 121. And I have silicosis myself, and it's impossible for me to get a job anywhere.
My husband, Cecil Jones, died of working in the Hawk's Nest tunnel, contracted silicosis.
And each and every day that I worked in that tunnel, I had to carry out 10 to 14 men was overcome by the dust.
The Hawk's Nest tragedy directly connected exposure to silica with silicosis and spurred public outcry for worker protection and workers' compensation. In 1938, then Secretary of Labor Francis Perkins commissioned a study on how to work more safely with silica.
After a year of work, the National Silicosis Conference Committee has just made its report of findings and recommendations. This report shows how silicosis occurs, where it occurs, and what the disease is, and it makes recommendations for its practical control. Above all, the report emphasizes that these control measures, if conscientiously adopted and applied, that silicosis can be prevented.
The 1938 recommendations were to work wet and use vacuums to minimize the dust. Unfortunately, these were merely suggestions and didn't have the teeth of enforcement. Many employers did follow the recommendations until technology advanced, making it possible to work dry. The new methods saved time and money, but caused a renewed increase in silicosis and other lung diseases.
In the early days of my career, I never saw a masonry saw that was not water covered. We couldn't. The blades would fall apart if they weren't wet. Since the wet dry blade came into effect, hey, the water stops going, we keep right on cutting.
The Occupational Safety and Health Administration wasn't established until 1971. That year, OSHA mandated a limit for the amount of silica a worker could be exposed to, but it didn't go far enough.
We already knew that the standard that went in place back in the early 70s was out of date the day it went into place.
Fast forward to 2016. After decades of trying, OSHA finally released a federal standard lowering the exposure limit by more than half and creating a series of recommendations for how to work safely with silica.
The Labor Department is announcing a final silica rule that updates the standards, saving more than 600 lives per year and protecting the health of thousands of others.
The recommendations are essentially the same ones they made in 1938. Work wet and use vacuums to eliminate or reduce dust at its source. It took nearly 80 years to get federal protection from silica, but now that it's in place, we need to use it. Workers need to learn more about the hazard and use the recommended controls. Always be aware of your surroundings and the work being done by other crafts, and take care not to bring the dust home on your clothes or person. Contractors must designate a competent person to control and monitor for silica on the job. Make sure your workers are using vacuums, water, substitutes, ventilation, or different work practices, and provide respiratory protection when needed. Too many workers have died from silica for too many years. We can work safely with silica. Let's do it.
So this is a short presentation. Let me go again to our regular class and continue with our presentation in a moment. Here we are. So let me see. This is the right one. Yeah, this is the right. Sorry. So the evolution is interesting. In the past, they know that the silica was affecting our workers. It was not clear how much. They knew that they could control the silica, respiratory silica, using some wet methods or vacuum absorbing all this dust, but they didn't implement anything until 2016, in which we have now table 1. And we are going to use table 1 in this presentation a lot. We are going to learn how to create a silica protection plan and all the other requirements the new law is asking us to implement with our workers. In this section, we are going to focus a little more about the training requirements for our workers that are included in the silica standard. So the standard requires employers to ensure that each employee who is covered by the silica standard can demonstrate knowledge and understanding of the health hazard associated with exposure to silica. And I told you yesterday that we have this new directive published on June 25th this year by OSHA. This directive is to the inspectors, and they are going to ask workers about this training. Have you received some training? Other questions that the inspector can ask is, do you know who is your competent person? Did your competent person came here to verify that you are okay regularly? How frequently are you revamping your plan, your silica protection plan? It should be revamped at least once in a year, and so on. But these are a requirement about the information or training for your worker is also something that they are going to ask, and they are going to require some documentation that shows that you were training your workers. Training requirements: the employer must ensure that employees trained under the silica standard can demonstrate knowledge and understanding. And how are they going to demonstrate knowledge and understanding is another question. How can we do it? Then we say employees must be trained on the health hazard associated with respiratory crystalline silica exposure. Overexposure can place the employee at risk for cancer and all the other illnesses that we were talking about. But we need to show that they were trained. There is no requirement where to provide the training or who should provide the training, but some training requirements: employees must be trained on the specific workplace tasks that could expose them to the respiratory crystalline silica. Look, 18 examples are listed on table 1, such milling, asphalt, and cladding concrete. For these activities, if you go to the OSHA webpage, you are going to find the fact sheets. Let me show you the fact sheets. I have all the fact sheets here. Okay, I downloaded all the fact sheets here, and each fact sheet is about one of these activities. Let's open one randomly. Opening this. This is how it looks. One of these fact sheets. So you can find fact sheets for almost every activity that you do in your work zone, and you can use these fact sheets to train your workers, because OSHA was not specific about what materials do you need to use, but it's interesting. They publish all these fact sheets, and you can use it to train your workers. So once a day, toolbox talk, before doing some activities, you can start printing these fact sheets and start the discussion with your workers. But it's important to at least have the materials that you're using. For example, you can print all these fact sheets. These are my materials, and you can have a list of the workers receiving the training. So ask them to sign a list regularly every time you are training them, because what OSHA is requiring is to provide training, but it is not requiring who is going to provide the training, where is it going to the training is going to be provided, and all these things. So some training requirements: employers must train employees on workplace specific engineer controls. In these fact sheets you have the engineer controls. Work practice controls or administrative controls, you have all the controls there. Also respiratory protection, you have it there also in these fact sheets. How do they need to use it, or implement all the controls method? How are you going to clean, do the maintenance? What methods are you going to use to remove the dust, to prevent the dust to airborne after you finish the work and you have to clean. So all these things are in, if each fact sheet has this information. So I recommend you to take a look to the OSHA webpage and download all these fact sheets, because they are going to help you to provide this training. It's going to be very easy. So the standard requires classroom training for employees. The standard does not require classroom training for employers. The standard does not specify how an employer needs to train the employees. The standard allows the employer to determine how training can be most effective and accomplished. You can use several methods, you know, but the thing is interesting. So you can do it in a toolbox talk. Yes, you can train your workers in the work site. You don't need to take to a classroom. So it doesn't specify how are you going to do the training either. But the thing is that they need to demonstrate knowledge about these hazards. So examples of acceptable forms of training: exercises, classrooms, written materials, PowerPoint, toolbox talks. You can figure out a way. But the interesting thing is that OSHA is not requiring us to use a specific method to train our workers. So how can employees demonstrate knowledge and understanding? There is no set method employers must use to ensure employees demonstrate knowledge and understanding. So just it is something that you have the freedom to interpret how are you going to demonstrate knowledge and understanding. But at least we have the directive. I recommend you to download the directive. I told you before, published on June 25th, because you are going to find a lot of information about the inspectors. When they are going to do the inspections, they are going to talk with the workers, and they are going to ask some questions, and some questions can be about this area. Show me that you know about this silica risk, and how are you going to protect yourself? So it could be a question that inspector can make to a worker. Knowledge demonstration: employers can determine whether employees have the requisite knowledge through methods such as required training subjects, written tests, oral quizzes. If you do this, it could be good to keep a record about the answers of the workers, because if there is an inspection, it's possible that they are going to say, show me that you provided training to your workers, and it could be a good way to show that the students or the workers demonstrate knowledge. Also, OSHA is not specific about how to do it. When is training required? Employees must be trained at the time they are assigned to a position involving exposure to respiratory crystalline silica. So it's important to do it before you start working, basically, to be most effective. Okay. Health hazard, we talked about all the health hazards yesterday. So it's important for your workers to know about it, because they need to be aware about the risk and protect themselves. And also you can train them how to do all these things, basically how to get information, how important is it for them to be safe. They have the power of information in their pockets now. Basically, when I am doing my face-to-face training, I ask the students, hey, let's Google a couple of things. Silica protection, OSHA Silica standard, OSHA Silica table 1, and they can browse it in their cell phones, and they are going to get all this information, and also the fact sheets also. I have another video here. Let me share it with you.
This video provides a brief overview and general information on respiratory hazards in construction and respiratory protection program requirements. The Federal Occupational Safety and Health Administration, also called OSHA, and state OSHA agencies require employers to have respiratory protection programs if their workers are required to wear respirators on the job. This video does not cover all of the things that your employer must do under federal OSHA or state OSHA respiratory protection standards. This video can be a part of the OSHA required respiratory protection training, which includes many topics, like how to put on and take off a respirator, and how to use, clean, and maintain your respirator. Your employer must also provide you with worksite specific training. While this video discusses some of your employer's responsibilities under OSHA's respiratory protection standard, it is important to remember that the purpose of a respirator is to protect your health and safety. Gases, dusts, mists, and fumes may be present at construction work sites. Some of these can make you sick or kill you if you breathe them in. These gases, dusts, mists, and fumes are referred to as respiratory hazards. Some respiratory hazards act quickly, like carbon monoxide, which can make you unconscious or kill you in minutes. Other respiratory hazards can take years to make you sick, like asbestos, which can cause lung cancer decades after you breathe it in. More examples of respiratory hazards in construction include lead dust and fumes from grinding, welding, cutting, or brazing surfaces coated with lead-based paint. Silica dust from cutting concrete or sandblasting. Solvent vapors from adhesives, paints, strippers, cleaning solvents, and spray coatings. And isocyanate vapors from spray foam insulation and certain spray paints or coatings. When there are respiratory hazards at your job site, your employer must use several methods to reduce your exposure to them, including engineering controls, such as local exhaust ventilation, work practice controls, such as using wet cutting techniques, and administrative controls, such as minimizing the number of workers exposed to the hazard. When you and your coworkers cannot be adequately protected from respiratory hazards through use of these methods, then your employer must provide you with an appropriate respirator to protect your health. Respiratory protection must be selected based on the hazard you will be exposed to on the job. Not every respirator will protect you against every hazard, so it's important for your employer to select the right one. For example, filtering face piece respirators may protect you against particulate hazards such as dusts. However, a filtering face piece respirator will not protect you against gas and vapor hazards like solvent vapors. If you are exposed to gases and vapors, you will need a different type of respirator. For example, you could use an air purifying respirator with chemical cartridges or an atmosphere supplying respirator, such as an airline respirator or self-contained breathing apparatus. In addition, atmosphere supplying respirators are the only respirators that will protect you against hazardous atmospheres, such as carbon monoxide and lack of oxygen. Selecting an appropriate respirator is your employer's responsibility. When respirators must be used on your job site, your employer must have a respiratory protection program. This program must meet the requirements of either the federal OSHA or your state OSHA respiratory protection standard. The standard requires your employer to do the following: develop and implement a written respiratory protection program. Evaluate the respiratory hazards in the workplace. select and provide appropriate respirators, provide worker medical evaluations and respirator fit testing, provide for the maintenance, storage, and cleaning of respirators, provide worker training about respiratory hazards and proper respirator use, evaluate workers' use of respirators and correct any problems, and provide you with access to specific records and documents, such as a written copy of your employer's respiratory protection program. Some of these requirements, such as training and fit testing, can be provided by an outside party, including a union, an apprenticeship program, a contractors association, or a past employer, provided they were conducted within the last 12 months. However, it is still your current employer's responsibility to ensure that all of the requirements of the standard have been met. Because each workplace is different, it is very important that your employer's respiratory protection program address the conditions found in your specific workplace. For example, workplaces may differ in the following ways: the types and amount of respiratory hazards present, the people who manage the program, the policies and procedures for tasks such as respirator selection, maintenance, and use, and other methods for controlling exposure, such as using wet cutting techniques to reduce airborne dusts. Since construction work settings change over time, the written program must be updated as necessary to account for those changes in workplace conditions that affect respirator use. For example, changes in workplace conditions could include new work processes or techniques, such as introducing sandblasting into an area, the use of new or different building materials or chemicals, changes in the amount of a respiratory hazard in the workplace, or changes in the types of respirators being used. Notify your supervisor if something changes in your workplace that conflicts with or may not be covered by your respirator training or established workplace policies or procedures. Your employer's respiratory protection program must be managed by a qualified, trained program administrator. This person must monitor the program and make sure that you and your coworkers are adequately protected. The program administrator will know a lot about your workplace respiratory protection program and should be able to answer any questions you may have about respirator use. The program administrator must know about the requirements of the OSHA respiratory protection standard and must periodically evaluate the program and make any necessary changes. This video has provided you with a brief overview of respiratory hazards in construction and respiratory protection program requirements. There are many other things that you must know and do before you can safely use a respirator in a hazardous work environment. While this video may be a part of your respiratory protection training, your employer must also provide you with additional training on respirators, including worksite-specific training. Remember, if you don't know if a respirator is needed for the task you will be doing, or if you are unsure about how to properly use a respirator or which filter or cartridge to use, talk to your supervisor before entering the hazardous area. For more information about respirator use in your workplace, refer to these OSHA and NIOSH websites.
So it is interesting to realize it's mandatory for every company to have a respiratory protection program. And it's also mandatory to every construction company to have a silica protection plan. So these things are different. A program is like some colleague described it interestingly. A program is a sort of a book with a lot of recipes for cooking anything. Okay, so a program involves several related topics in one area. For example, respiratory protection program can involve, for example, silica protection, lead protection, asbestos protection, gases protection. but all these are respiratory protection. So, and Silica protection plan is only one of the topics of this respiratory protection program, but both are mandatory, and the training is required in any case. So just in case to realize what is the difference between a program and a program is a sort of a set of topics related in a safety area, and a plan only covers one of the topics in a program. In this case, we are talking only about the Silica protection plan that belongs to a biggest area called respiratory protection program. So additional training, hazard communication program. Yes, we are talking about a sort of, it's a chemical. The crystalline silica is a chemical. So we need to provide training to our workers related with any chemical that they are working with, and also the respiratory protection program. Of course, we watched it in the video before. So hazard communication standards, remember it's a chemical. Employers must comply with OSHA hazard communication standard. We need to train our workers to understand all these the relevant pictograms for their jobs. We were talking about it yesterday. They need to talk about respirator. We need to talk about respirator and train them about respirators. So look, common sense is not so common. So we need to provide training how to use a mask, for example. Okay, so it's mandatory to provide training for all these things related with respirators, for example. Respirators are needed when engineer controls and work practices or administrative controls are not enough to safely control exposure levels of silica. Employers must still use engineer and work practice controls to minimize exposures. So respirators, again, it's important to provide training to employees on how to properly use respirators. For example, in this case, we can see this guy is using a beard, a mustache. So sometimes it's not all this hair is not going to allow him to have the respirator or the mask touching his face completely, and there is going to be some filtration of contaminated air. So we need to shave the faces to use respirator, for example. When a respirator is required during table 1 tasks that require respirator use, you can see your table 1. You are going to realize again, in some cases, if we are following table 1, we don't need to use any mask, any respirator. In other cases, we are going to require to use masks or respirators after 4 hours of working. In other cases, we need to use respirator at any time, all the time. Okay, it depends on the circumstances. What kind of activity are you doing? Okay, but basically, we need to use it according to the table 1 when the exposure exceeds or is expected to exceed the permissible level. It's 50 micrograms per cubic meter in 8-hour exposure. So, but you are going to see using table 1 whenever you need to use a mask, it means that you are above the permissible level, exposure level. There, where an exposure assessment has not been documented, yes, if you are not sure about how much, for example, if you decide not to use table 1, you are not sure about the exposure of silica in the air to your workers, and you didn't took a test, sent some samples to the lab, you don't know what is the level of contamination, your workers need to use the mask too. If an employee is required to wear a respirator at any time during a work shift, this counts as 1 day toward the 30-day requirement. Look, there is a requirement. When you have your workers working with respirators during the 30 days, there is a requirement to send your worker to the doctor to verify that everything is okay with his or her lungs. And this is interesting because anytime you according to table 1, you're following table 1, your worker need to use a respirator. it counts as 1 day. So that's important to think about, maybe rotating our workers to prevent them to be working more than 4 hours in some cases, so they don't need to use a mask. A sort of a rotation method, just to prevent them to accumulate these 30 days of using a mask. That is going to trigger the need to take your worker to the doctor, just in case. Then what respirators can be used for silica? NIOSH tested all certified particulate or supplied air respirator may be used for silica protection, only approved by NIOSH, okay? And when the law is, when you go to table 1 again, it is asking us to use masks or respirators with the APF of 10. In many cases, only there is one case in which it's required an APF of 25. But basically, APF is assigned protection factor. So assigned protection factor of 10 means, for example, an N95 mask or an elastomeric mask. So the N95 is a piece of paper with a filter fitting in your face, but it's disposable, you know. But the elastomeric mask is a mask, half a face mask. It has some filters. We can keep using the mask, but we can change the filter whenever it's needed. So these are 2 options to fulfill with the requirement of OSHA. We have because of COVID-19 problems, we have the situation in which we don't have enough N95 masks. You know that doctors or people working in the health industry have been requiring a lot of N95. So there was a scarcity about where to find the N95. So OSHA has developed several communications, letters, interpretation letters, basically saying, hey, there are some alternatives. If you need to reuse some N95, there are some methods to do it. If you don't have access to N95 mask, maybe you can use another kind of face of respiratory protection with APA higher, maybe 25, maybe 50. But OSHA didn't say that you are allowed to work without using any protection, okay? You have to use a protection. In addition to this, OSHA is saying, well, the CDCs are saying that workers in construction are essential workers, but thinking about COVID-19, they are suggesting workers to use bandanas or any other kind of mask, keep a safe distance. We're going to talk a little more about it later when we talk about COVID-19 and the construction industry. But the idea is OSHA is requiring people to continue using masks whenever it's required according to the law. There is no exception. If you cannot find an N95 mask, OSHA says, well, you can use another mask with a higher assigned protection factor, maybe 25 or 50 instead of 10. So that was the solution that we have. In addition to this, I share with you a new information published by OSHA some days ago. It is the Understanding Compliance with OSHA Respiratory Protection Standard during the Coronavirus Disease 2019 COVID-19 pandemic. It was published just some days ago. You have it in your documents, attached documents. So you can take a look because it has the interpretation from OSHA about the problems that we have with the N95 mask and how can we solve these problems and all the criteria they are using to solve this problem. But basically what it's saying is, hey, if you demonstrate that you are doing your best effort to follow the law, the inspector is not going to put you a fine, but you have to demonstrate that you are trying to follow the law. We understand that the N95 are not available in the market because of this situation, but there are some alternatives and you need to explore these this document. Let me show you. I have this document here. So when you go and visit your attached documents, you can find this document there. So take a look to this information to help you to fulfill with the law and protect your workers in these difficult circumstances. Okay, so we have here some additional information, sources of all additional information, and so on. So let's continue with the next module. Okay. So, okay. Now we are going to talk a little more about Table 1. Okay, and Table 1 and the alternatives we have to fulfill with the law. We have two choices. Or we follow Table 1 with all the 18 different tasks, situations in which we can produce crystalline silica dust or respirable crystalline silica. So, and the law says if you follow Table 1 and all the methods to prevent crystalline silica airborne, you are going to fulfill with the law. So that's it. Follow Table 1 and your OSHA inspector is going to be happy. Okay, that's an alternative. And we're going to talk more about it. Okay. And the other choice is, well, you don't want to follow Table 1 because maybe the activity you are doing is not included in the 18 activities in Table 1. So you have this other alternative exposure control method. Okay, one is the performance monitoring option and the other one is the schedule monitoring option. Basically, the performance monitoring option is requiring you to create a sort of average about the activities your workers are doing and protect them according to the activities they are realizing. The schedule monitoring option is basically considering what they are doing in the according to the process, the activity, the construction they are doing in time, and take the evaluations according to this process. Let's explore a little more about all these alternatives we have. So when using Table 1, when a respirator is not required by Table 1, the employee exposure is above the action level and below the permissible exposure level. However, when a respirator is required, it is assumed the employee exposure is above the permissible exposure level. Let's understand this using these graphics maybe. The OSHA standard requires employers to develop and implement a breathing exposure control plan. It's mandatory in any case. You follow in Table 1 or not, it's mandatory to have a plan, okay? This plan describes both work tasks and workplace areas where exposure occur. The plan also outlines what actions are going to take place to eliminate and reduce exposure. So you have to include these things in your plan. Don't worry about it. We are going to learn how to do a plan. We are going to have some formats. It's not so difficult. When we are going to, after doing all these exercises, you are going to understand completely how to do all these things. It's not so difficult. Then the plan must include all work tasks where exposure is anticipated, along with the equipment and materials used. User must follow manufacturer recommendations too. Yeah, it's in the plan. We are going to learn how to do the plan, and it's going to be clear all these areas. For example, one thing that exposure control plan must include in any circumstances. Maybe you're following Plan 1 or Table 1, or maybe you are not, but you have to follow this. Include these topics in your plan. Okay. First, a description of the tasks in the workplace that involve exposure to respirable crystalline silica. You have to describe what task are we going to do. Then a description of the engineer controls, work practices, and respiratory protection used to limit employees' exposure to respirable crystalline silica for each task. Okay, you have the task. Now you need to describe what engineer methods, what administrative methods are you going to implement to prevent this dust to airborne, basically. What are you going to do to control this? What activity? First one is what activity are you going to do that produces the dust? Second is what method are you going to use to control the dust? Third, a description of the housekeeping measures used to limit employee exposure to respiratory crystalline silica. Okay, you have to do some maintenance, housekeeping. How are you going to do it? In a way in which you are going to prevent the dust to airborne. Okay, again, using water or a aspirator or a wet aspirator to get all the slush, all this silica with water. Fourth, a description of the procedures used to restrict access to work areas. Well, they are talking basically here about administrative controls. For example, using some warning signs, some signs to prevent workers to go in an area in which they can have some exposures. When necessary, to minimize the number of employees exposed to respiratory crystalline silica and their level of exposure, including exposure generated by other employers or sole proprietors. So sometimes there are workers producing silica and they are protected, but the other workers around, they are not. So that's important. How are we going to limit access to other workers in that area and exposure to third parties too? Then fifth, make sure the exposure control plan is available. It is important. So look, we are talking, if you're just following table 1, you have 18 different activities, okay? And each activity is going to require a plan, okay? It's something that maybe it looks like a lot of jobs, but it's what is required. So for each activity, you need a plan. And also you need copies of the plan. So we are not talking about only one plan, okay? We are talking about several plans for each activity. And we are going to learn again how to create a plan for each activity, okay? But that's what the law is requiring. So you have an OSHA inspector, the inspector is going to require, okay, show me your silica protection plan. And maybe you are going to need to show him 5, 10 different plans according to each task, because each task, each activity is going to require a plan. Okay, and you need to have copies because the OSHA inspector is going to ask you for a copy, and also it's required for you to have copies available for your workers. Any people who could require to know about the plan, they should have a copy available of the plan. So it's important to take note about, make sure the exposure control plan is available. It's talking about having copies or have a photocopy there to be ready to be used to get copies, but that's the idea. Additional requirements in the plan. OSHA requires that the employer shall review and evaluate the effectiveness of the written exposure control plan at least annually and update it as necessary. So look, it's not enough to have the plan. They are going to require you to update the plan at least annually, okay? So it's one of the questions. You go to the directive of OSHA about the silica inspection, it's some of the questions that the inspector is going to ask. Are you revamping your plan? How was the last time you revamped your plan? So then we have this, the employer shall designate a competent person to make frequent and regular inspections of job sites, materials, and equipment to implement the written exposure control plan. So there is a big discussion about who is a competent person, okay? Competent person is an individual who is capable of identifying existing and foreseeable respirable crystalline silica, authorized to take prompt corrective measures to eliminate or minimize them, has the knowledge and ability to implement the written exposure control plan, okay? Look, there are many competent persons training now for protection training, confined space, different competent persons in different areas. But we have to emphasize something. It's not enough for somebody to go to a class and know a lot about the topic to be a competent person. The company needs to give that person authority. Okay, without the authority given by the company to that person, this authority to take prompt corrective measures to eliminate or minimize the hazards, without that authority, you don't have a competent person. You have somebody who knows a lot about the topic, but he is not a competent person. To be a competent person is basically the employer who is giving this person the authority to take the prompt corrective measure to eliminate or minimize the hazards. Okay, so just in case, many people saying, hey, yeah, I have a competent person because he went to a class. No, if the company didn't give this person the authority, that's not a competent person. And by the way, in the directive, again, it's one of the questions the inspector is going to ask the workers is, tell me who is your competent person. And look, what we have in OSHA is interesting. As I told you, OSHA requiring competent persons in a lot of different hazards: fall protection, silica protection, confined spaces. So maybe it's a good idea to have a sort of chart or pocket chart that your workers could keep with them to know who is his or her competent person in each area. Because now we have different competent persons. Of course, a competent person in general could be the foreman, you know. He has the knowledge and the authority in general. But now OSHA is allowing to have more competent persons in different areas, specific areas. And part of the inspection, the inspector can ask the worker, who is your competent person in silica protection? And they should be ready to provide information. When was the last time your competent person came to give you some advice or training or verify that everything was okay? And they should be ready to provide some answers. It's interesting, if we go and visit this webpage, the American Industrial Hygiene Association has developed a guideline, recommended skills and capabilities for silica competent persons. So they create a sort of blueprint how to train a competent person, but again, is the training. The training is not creating a competent person. It's the authority that the company provides to the person that becomes also the person a competent person. It's not only enough to have the knowledge. It's required to have the authority. Then CPWR has developed tools to provide guidance on developing site-specific reading exposure control plan. Look, again, I told you about it yesterday. You can visit this CPWR webpage or just browse it. CPWR Silica Protection Plan, and you are going to go to a web page in which you are going to find a sequence of questions that if you answer these questions, at the end, you are going to have a plan, a silica protection plan. Okay, and you can repeat this sequence for all the 18 different tasks you have in the table 1, or if you don't have it, you would prefer to use not to follow table 1, but as CPWR has very good information, if you also don't want to follow table 1 with information, objective information, scientific research information to create a silica plan. So a little more about table 1. What is table 1 and how it's applied? Table 1 is a tool provided in the OSHA Silica Construction Standard that outlines 18 specific tasks common to the construction industry. This tool presents ways to control employee exposure to silica, and it's very useful. Okay, very useful. How to find table 1? Again, you can browse it. OSHA Silica table 1. Just do it. If you have a cell phone there, or you are in your computer, or later, or take a note, OSHA Silica table 1, and you are going to find it very easy. Okay, let me show you. I have it ready here at table 1, and you have it too. I send it to you. This is my table 1. Okay, with 18 different activities. And look, it's interesting. You have the activity, the tasks, the equipment that you're using, the tasks, then the engineer control methods that you're going to use, and then the personal protective equipment or respirators that you need to use. Okay, basically using this information, you can start creating a plan. It doesn't include information about, for example, how are you going to do the cleaning and maintenance or the administrative methods that you need to use. But if you go to CPWR webpage and also browse its Silica 1 table, you are going to find this. Let me show you. Yes. This is a table 1 created by CPWR using the original table 1, but it has all the information that you need to use to create a plan, customize a plan according to the activity you are doing. So it's basically the same table 1 plus additional information. For example, it includes some pictures, the control methods, respiratory methods, some tips here in this area. So instead of having just 3 columns, it has 1, 2, 3, 4 columns. So with all this information, basically you can create a plan. Okay, and we are going to learn how to create a plan. But you can browse it, CPWR Silica table 1, and you are going to find it. Okay, it's not so difficult. But table 1 is very, very useful. It's very interesting. Don't at the beginning I was thinking, oh wow, it's going to be difficult to understand all these things. But when you get all this practice and after this training, I'm sure that you are going to be comfortable working with table 1. Again, specified exposure control methods, table 1 of OSHA rule. Employers who follow table 1 correctly are not required to measure workers' exposure to silica and are not subject to the permissible exposure level. So it's interesting because you follow table 1, you are not required to take samples of the atmosphere and send it to the lab. Okay, it's something important. If you are not following table 1, you are going to need samples of the air and send it to the lab to evaluate what is the level of contamination with silica. But if not, if you are just following table 1, OSHA says, okay, you don't need to send anything to the lab. So just have a plan and follow the table 1, and that's going to be okay. It's interesting how OSHA is making it easier for everybody to follow table 1 or prefer to use table 1. Oops. Mandatory actions for alternative exposure control methods. Yes, if you don't follow table 1, you are going to you need to work with these limits, and it's also applied to the table 1, but we're going to talk a little more about it later. But basically, this is some good concepts that we need to know. Action level. If you are below the action level, which is 25 micrograms per cubic meter of air during 8 hours time weighted average. If you are below this limit, you don't need to provide any method to protect your workers. You're working okay because the level is not enough to affect your workers. You don't need to use any administrative control or engineer control or provide mass to your workers because your activity is not producing enough silica. Okay, but if your activity produces 25 micrograms or more, and you are below this permissible exposure limit of 50 micrograms, now you are going to follow table 1 and find the solutions using all the methods, engineer methods, administrative methods that we have there. And maybe you don't need your worker to use any respirator. But if you are above this, after using all these administrative methods, all these engineer control methods, you are above this permissible exposure limit, now you need to use a respirator, a mask, an N95, elastomeric mask, or another mask, according to the requirements from table 1. That's why it's important to know these limits. Below 25 micrograms, you don't need to do anything. Between 25 and 50, you need to implement all the engineer control methods and administrative control methods. But if you are above 50 micrograms, you need, in addition to this, provide masks, PPE to your workers. Okay. Prohibited actions, dry sweeping, compressed air cleaning, dry brushing. The idea is we don't want to produce dust, okay? Some perspectives about here, we can, to understand how much is 50 micrograms, you can compare it again with a cent coin, or have this amount of dust distributed in this area, 20 cubic meters of air. Another way somebody explained me before is you can fill a teaspoon with powder and distribute it in the middle of 50,000 people stadium. So you can fill a teaspoon with silica and throw it through the air in the middle of 50,000 people stadium, and that's again an idea about the exposure of silica during 8 hours a day. But if we don't protect the work, you can say, no, it's not enough, right? It's so little, yes, but if you consider it that your workers are going to work in this environment day after day after day, all this dust could accumulate in their lungs and they are not going to leave it. Well, it is 11:01. We are going to have a short break. Before going to the break, Paula has some poll to conduct with you. So Paula, are you ready with a question?
I am ready. There's no questions for you in the chat box, so I'll go ahead and launch the poll right now.
Good.
Just a second. So please hit the escape key to vote on your screen. I'll go ahead and read the question. To protect against silica, it is recommended that workers have a change of clothes for work and another to go out or return to their homes. True or false? Again, to protect against silica, we have about 52% who voted. I'll give you another few seconds here. We are going to see who was participating. So it's a true or false. To protect against silica, it is recommended that workers have a change of clothes for work and another to go out or return to their homes. True or false? All right, I will share those results. 95% said true, 5% said false.
Yes, it is true. The right answer is true. It is recommended to have a different set of clothes, not only because of the silicon contamination, but also because we have lead contamination, asbestos contamination, and we don't want to take all these contaminants to our homes, okay, or to be in our cars. We don't want to affect our children or wife or dogs, pets, or anything. So that's why it's recommended to follow this hygiene method, having a different set of clothes for working and for going to the streets, and you are going to help not only you but your family to be safe and before silica and lead and asbestos and other contaminants. So we are going to take a break. Let's continue at 11:10. Okay, I have 11:03. Let's continue at 11:10. See you later. Thank you. Okay, are we ready?
We're good.
Okay, let's continue. This is a comparison. This table is comparing if you follow table 1 and if you are not following table 1. Okay, if you're following table 1, you don't need to fulfill with these requirements. For example, the permissible exposure level, you are not required to do the evaluation. Exposure assessment, you don't require to take any sample to the lab. Methods of compliance, no, you don't need it because you are following table 1 and all the methods of compliance are there in table 1. Respiratory protection, yes, if respirators use is required by table 1. In some cases it's required, in some cases you need the respirator. Housekeeping, yes, you have to. Breathing exposure control plan, yes. Medical surveillance, yes. When you have your workers working with a respirator 30 days or more, you need to send them to the doctor. Communication of hazard, yes, you have to train your workers to make them aware about the problem. Record keeping, yes, for any employees who are getting medical examination, yes, you have to keep the records. If you are not following table 1, you are required to follow and evaluate the permissible exposure level for your workers, do the exposure assessment, send some samples to the lab and get the results to know what is the level of exposure for your workers. Methods of compliance, yes, you have to implement additional methods of compliance because you are not following table 1, you are following another set of rules. And the others are the same. But it is interesting how if you follow table 1 or try to follow table 1 or accommodate your activities to table 1, you just follow table 1 and you are going to be okay. You don't need to do additional assessments, evaluation of the atmosphere, and all these things. But if you are not following table 1, you need to do these additional tests and evaluation for your workers. Okay. So CPWR's exposure control database is interesting because in some cases you have activities that are not included in table 1, and you need some objective data to prepare your Silica protection plan. And CPWS has resources to help predict silica exposure in the workplace based on tasks. So it can help you to create your own plan. In addition to table 1 tasks, the database has information on jobs that produce respiratory crystal and silica but are not listed in table 1. It provides useful resources and cites the sources from where I have somebody here trying to contact me. Don't worry about it. It provides useful resources and cities that let me wait a second, please. Let me unplug it. It's not here. Okay, let's continue. Oops. Yeah. So if you are not going to follow table 1, you can go to this web page, CPWRs, and they have additional activities not included in table 1, objective data that is going to help you to create your own plan. Okay, and what method are you going to use to control the dust, to clean the dust, administrative methods, and all these things. So it's going to be, it's a very helpful web page. If you are not following table 1, you can find objective data to create your own plan. Examples of silica dust producing tasks, yeah, we were talking about it before. All these activities can produce this silica dust. So, yep, you have a sample of people doing activities producing this dust. You can see the dust, and that's the problem. We don't want it. We need to control it using spray, using a vacuum, or isolating our workers. But in these cases, look, it is crazy. You can see all this dust is not only affecting your workers, but also people around, just pedestrians. Or you have people doing some activities, and sometimes you have a flagger person here. He or she is doing nothing with the dust, but basically because this person is in this environment, he is or she is also contaminated with all this dust. So these are violations for the OSHA standards. Okay, let's do an example using table 1. We are going to do this water control methods for the use of the jackhammer. You have to use a jackhammer. Somebody put that here. Jackhammer, and you have 2 alternatives. You can use some spray water, or you can use a vacuum to absorb all this dust. So we are using here the table 1 from CPWR, and we can identify that this activity is in the activity number 10. So you can go to table 1 and go to activity number 10, and you are going to find jackhammer. And we have these pictures here. Also the water control method. There is another page in the table 1 that is going to show us the vacuum control method and all the when do you need to use a mask. If you are working outdoors, you don't need to use a mask if you are working less than 4 hours. But if you are working more than 4 hours outdoors, you need to use a mask. But if you are working indoors, you need to have a mask all the time. So you have this information also here. And let's see, for example, when we use the water control method, okay, using table 1, we can have this summary. It's required, for example, using the engineer control, but we are going to use water. And also we need to use respirators. Use tool with water delivery system that supplies a continuous stream of spray of water at the point of impact. require respiratory protection. As we said before, if you are working outdoors below 4 hours, you don't need any. But if you're working more than 4 hours, you need a respirator. But if you're working indoors, you need a respirator at any time. Okay. So this is the condition. Engineer controls. In this case, well, we are using water here. In this case, we are using a ventilator, a vacuum also. So similar use tool with commercial available shroud or dust collection system, operate and maintain tool in accordance with manufacturer instruction to minimize dust. Dust collector must provide the airflow recommended by the tool manufacturer or grader and have a filter with 99 or greater efficiency and a filter cleaning system. All these things you need to put inside of your plan. Okay. Require respirators? Yes, same as the water control, indoors, outdoors, it depends. Now we are going to watch a video. This video was created by OSHA just for this activity. It's a sort of sample, okay, just for this activity. And they are going to talk about both methods, the water methods and the vacuum method. But it's the same activity. We are working with a jackhammer.
The Occupational Safety and Health Administration requires employers to limit workers' exposure to respirable crystalline silica on the job. This is one of a series of videos showing dust control methods that OSHA specifies for many common construction tasks in Table 1 of the Respirable Crystalline Silica Standard for Construction.
You can see here, they are talking about Table 1 and going to this activity number 10 in Roman numbers. Jackhammers and handheld power chipping tools. So we have this section that we have to use from Table 1, just this section.
When used properly, these methods are effective in limiting workers' exposure to respirable crystalline silica dust. This video describes two methods that can be used to control dust when using a jackhammer or handheld power chipping tool on materials that contain crystalline silica: a water delivery system, or a commercially available shroud and dust collection system. First, let's review the full and proper use of a water delivery system. To control dust created by a jackhammer or handheld powered chipping tool, workers can use the jackhammer or chipping tool with a water delivery system. To comply with Table 1, the water delivery system must supply a continuous stream or spray of water to the point of impact. For example, a helper can spray a continuous stream of water at the point of impact from a portable pressurized canister or from a hose connected to a water faucet or water tank. Alternatively, the water delivery system can be mounted permanently on the tool. Instructions for retrofitting jackhammers with water delivery systems are available at www.osha.gov/silica. Whether water is sprayed by a helper or by a water delivery system mounted on the tool, make sure the amount of water is sufficient to minimize release of visible dust. It's also important to correctly maintain the water delivery system. When the water delivery system is not working properly, dust is not effectively controlled. With regular use, hand pumps can wear out, hoses can become pinched, hose connections may fail, and nozzles can become clogged. To make sure a continuous stream of water is applied at the point of impact, operators should regularly check that the water supply is sufficient. Check nozzles for damage, remove clogs, and be sure hoses and connections are intact and functioning correctly. Now, let's review the full and proper use of a commercially available shroud and dust collection system. A shroud and dust collection system can control dust created by a jackhammer or handheld powered chipping tool. To comply with Table 1, the dust collector must provide the airflow recommended by the tool manufacturer and have a filter with 99% or greater efficiency and a filter cleaning mechanism. It's also important to correctly maintain the dust collection system. When the dust collection system is not working properly, dust is not effectively controlled. With regular use, the shroud or cowling can become excessively worn, vacuum hoses can become clogged, filters can become overloaded, and dust collection bags will fill up. To help ensure the system is working correctly to minimize dust emissions, the shroud must be intact and installed according to the manufacturer's instructions. The jackhammer or chipping tool must also be operated and maintained in accordance with the manufacturer's instructions to minimize dust emissions. Instructions often direct users to keep tools sharp, regularly check the dust collection system for signs of damage, make sure the hose connecting the tool to the vacuum is intact and without kinks or tight bends that can reduce airflow and dust collection. Replace the filter regularly or as needed. Do not overfill the waste container and follow a specified maintenance schedule. Be sure used filters and dust collection bags are handled in a manner that will minimize workers' exposure to silica dust. As long as either of the specified dust control methods is followed when using a jackhammer or handheld powered chipping tool, and the task is performed outdoors for 4 hours or less during a shift, the tool operator and workers who are assisting the operator are not required to wear respirators. If the task is performed outdoors for more than 4 hours during a shift, or indoors, or in an enclosed area for any length of time, the tool operator and workers assisting the operator must use respirators with an assigned protection factor of at least 10. When respirators are required, they must be put on before beginning the task and must be worn the entire time the task is performed. When respirators are used, the employer must comply with OSHA's respiratory protection standard. Using a jackhammer or handheld powered chipping tool indoors or in an enclosed area requires an exhaust method, such as a portable fan, as needed to minimize the accumulation of visible airborne dust. Be sure that any exhaust method chosen moves airborne dust away from workers and does not block an exit route. Employers who fully and properly implement the appropriate dust control methods specified by OSHA in Table 1 are not required to measure the tool operator's exposure to respirable crystalline silica or the exposure of other workers assisting with the task. The respirable crystalline silica standard for construction also includes additional requirements to protect workers exposed to respirable crystalline silica. Many of these requirements apply whether employers are using a dust control method specified by OSHA in Table 1 or an alternative dust control method. More information on the standard's requirements to protect workers exposed to respirable crystalline silica, including information on specified exposure control methods for other common construction tasks, can be found at www.osha.gov/silica. For information about other OSHA health and safety standards, visit www.osha.gov.
I recommend you to visit this webpage. We don't have time to cover all the 18 different activities, but if you go to this OSHA webpage, OSHA.gov Silica webpage, you are going to find again the fact sheets for each of these 18 activities and some videos like this one related with one activity. Maybe there are 5 different activities, the most important activities. You have videos for each of them. But the idea is to use Table 1 to create a plan. Okay, we are going to learn now in some minutes how to create a plan using some examples, but this is the idea.
Or call OSHA at 1-800-321-OSHA.
Use this information to allow you to get the idea how can you get more information because it's available, so it's not so difficult to get it. So also again, CPWR has this Silica checklist. It's another web page in which you are going to complete all this information, and it is going to produce or give you some advice about how to improve safety for your workers and also produce the plan. What about you need tasks that arise and are not listed in Table 1? That's why you have to follow the alternative method. Not to Table 1, but all the other alternative methods. Okay. It is essential that a qualified person conducts initial monitoring. Look, according to the law, in this case, a qualified person conducts initial monitoring, not a competent person, but a qualified person. Okay. As soon as work begins, so it's important. If you are going to begin or start an activity not included in Table 1, you cannot follow Table 1 for any reason. You have to start doing initial monitoring. It means basically take a sample and send it to the lab and get the information about what is the level of exposure. If it is below 25 micrograms, you don't need to do anything. If it is between 25 and 50 micrograms, you need to follow some administrative and engineer methods to control the dust. And if it is more than 50 micrograms, you need, in addition to the methods, administrative or engineer methods, you need to use or provide masks to your workers. Okay. So then OSHA intends for employers using the schedule monitoring option to conduct the initial monitoring as soon as work begins, so they are aware of the exposure levels and where control measures are needed. Yes, workers need to know about what is the result of the exposure assessment. Okay, it's important to provide this information to the workers too. So this was the break, but we are not going to do it. We are going to talk a little about alternative exposure control methods, although we don't have a lot of time. But just in case, you have this information in your handouts. Not everybody follow the alternative control methods now, but you can go to the law and follow these indications. Again, they are going to repeat what these graphics are repeating what I told you about the exposure limit. If it is above the 50 micrograms or between 50 or 25 and 50 micrograms or below 25 micrograms is what I was telling you before. So you have to follow this instruction. Not everybody is going to use it, but you have this information there just in case if you need to use all this. Create your own plan, different from the table one. Okay, it's a little complex, these topics, but we don't have enough time. We are going to create a plan now. How are we going to create a silica protection plan following table one? So again, we are following table one. We need to create an exposure control plan. The law doesn't require, in this case, to have a competent person or a qualified person. It can be written by anybody. It's interesting. It's not a requirement. And we need to provide all these things, the description of the task in the workplace that involve exposure to respiratory crystalline silica. So let's do this. You have the activity number 1, 2, and 3, I think. Okay, you can use now activity number 1. Let me put activity number 1 here. And this is the activity, okay? You have this situation. Using the template provided on OSHA's table 1, you need to use the table 1 now. And you are going to find, they are just giving us a tip, task number 8. You can go to the table 1, task number 8, because that's the situation we are going to use. So create a silica exposure plan for the following activity. This is the activity. Drilling holes for dowel bars in the edge of concrete paving using a gang drill. So this one, you go to task 8, number 8, and you are going to find this activity. So workers are be assigned to drill vertical dowel bar holes in the edge of previously poured concrete paving. Each employee assigned to the drilling task will be rotated every 3 hours. So now you go to table 1, activity number 8. Go to activity number 8 here, dowel drilling rigs for concrete, and you have the engineering methods that you need to use. For task performance outdoors only, use a shroud around drill bit with dust collection system and all this information, okay? And look, it is requiring for workers to use masks all the time. Look at this, less than 4 hours, APF 10, it means N95 or an elastomeric mask, anything with a assigned protection factor of 10. More than 4 hours, also 10, okay? So how I'm going to use this in my plan? Let me go to my plan. Where is my plan here? Let me move my plan here. This is the activity is solved now, okay? But I'm going to, after this training, I'm going to send to Paula the answer for these activities, so you can have a plan for each of these activities and you can follow the idea that we are going to share with you. In a plan, you need to put what is the name of the company, what is the name of the project, site address, date. You need to put the date when you are creating the plan, person completing the plan, who is a competent person. You put the name of the competent person, description of tasks. Again, you use the activity workers with drilling vertical double bar holes in the edge of previously poured concrete paving. So it's the same activity. Control descriptions. Basically, you can use what equipment are you going to use, and basically you can summarize it. The exposure control plan has been developed in accordance with the guidelines in 1926 1153 table 1 task 8, just to summarize it. And you can describe the work practices. To do these work practices, you can use either, for example, the CPWR table 1, in which they are going to describe some tips about work practices that you have to follow to fulfill with the law. Or you can go and use the OSHA fact sheets, find activity number 8, and copy and paste these work practices here in your plan. That's what we did. We copy and paste the fact sheet and put the information here for work practice. Then respiratory protection, yes, it's mandatory for us as we watch in the table 1. It's mandatory to use respiratory protection APF of 10, which means N95 or an elastomeric mask. So we can copy and paste again all this information from the fact sheets. And housekeeping, when we start with housekeeping and restriction access to work areas, notes, and actions, basically it's the same in all these 18 different situations. Basically, we are going to, it depends, of course, if you are using water or spraying water or a vacuum, a dust collecting system, you can use basically the same information and so on. Okay, and that's it. You have here a plan just for this kind of activities. Okay, and remember, you are going to need to create a plan for each activity that you are going to require in your work zone. So similar to this, we can use another activity. You have activity number 2. Oh, this one is in Spanish, sorry. But that's basically the idea. I was providing training the other day in Spanish, so. But you get the idea. How can we create these plans? Or this is another example. Let me just go here. This is the written silica. It's another example, another activity. This is activity number 7. You can go to your table 1 and find activity number 7, handheld and stand mounted drills, including impact and rotary hammer drills. You are going to do this activity, and you can use table 1 to identify what activity you are going to do. Work practices, you can get these work practices going to the fact sheets activity number 7 and copy and paste and continue with this idea. Basically, you can create easily your own silica protection plan customized to each activity you are going to do. Okay, this is one way to do it. You can also go to the CPWR webpage. In that webpage, they are going to help you to create your own silica protection plan according to the information you provide. So you can print it and use it and keep it and share it and implement it. But as I told you, it's not only enough to have a plan. You know, you have to execute the plan. You have to supervise that everybody is fulfilling with the plan. You have to train your workers. You have to design a competent person. It's important in this situation because the inspectors, the OSHA inspector, can ask about all these topics. By the way, before we have the COVID-19 crisis, OSHA was planning to dedicate this year to focalize their inspection on silica protection. I don't know if how are they going with this idea, but that was the initial plan, to focus very much on the silica protection. So what I'm going to do is, for each activity you have there, I'm going to send you a plan. Okay, it's a sort of example. And I recommend you very much to visit the OSHA Silica web page. Review these videos that we were sharing before, and also download all the fact sheets. Per each activity, you are going to find a fact sheet that's going to help you to fill each plan. Okay. So this is basically what I wanted to share with you about how to create a. Let's review very fast. What do we have here for? Let's see. Yeah. Let's review again how to create a plan. No, exposure control plans must include at least the following elements: a description of the tasks. Okay, you have the task in the workplace that involve exposure to respiratory crystalline silica. Then a description of the engineer controls work practices. You can get these control practices, engineer control practices, from table number 1. And respiratory protection used to limit employee exposure to respiratory crystalline silica for each task. You can get this information also from table number 1. In some cases, it's mandatory to use all the time the mask. In some cases, it's only required after 4 hours. In some cases, you don't require to use it. And it depends also if you are working indoors or outdoors. So you have to be aware about this situation. Then it's mandatory to have a description of the housekeeping measures used to limit employee exposure to respiratory crystalline silica. This information, you can get this information especially from the fact sheets. Not table 1, they are not going to give you, they are going to give you the engineer method, but they are not going to give you the housekeeping method. But you can get it from all these fact sheets. A description of the procedures used to restrict access to work area to minimize the number of employees exposed. This is an administrative method that is basically provided again in the fact sheets. So you can copy and paste whatever is in your fact sheets according to the tasks, the number of the tasks you find for your activity. Then OSHA requires that the employer shall review and evaluate the effectiveness of the breathing exposure control plan at least annually and update it as necessary. Okay, it's one question that the inspector is going to ask you. Are you revamping your plan regularly? Additional requirements: upon request, the employer must provide a copy of the breathing exposure control plan to cover employees, designated representatives, and OSHA. So you need to have copies of your plan ready to share it with your workers and OSHA and representatives. The employer shall designate a competent person to make frequent and regular inspection. We were talking about competent person before. Yeah, we talked about the competent person before. Where can we find exposure control plan resources? Again, visit CPWR. As I told you, they have this information available for everybody. And you can use the sample written silica control plans that I'm going to send to you after we finish this presentation, so you can get an idea how to create a plan and use this same format for other plans. So I'm going to send you a template, an empty template too. Okay, we did activity number 1 as a sample, and that's it. So this is the end of the section about silica protection. I want to go very fast to our COVID-19 protection. Okay. You know what is COVID. We have been familiarized with this emergency, this pandemic now. It happened in China, but it's around the world now. What makes it different from other respiratory infections is that this virus is very tricky, you know. You can be infected and you don't know, and you can start infecting other people and you don't know that you are sick. Other kind of SARS or COVIDs before, you began to transmit this illness when you had the symptoms. But in this case, you can transmit all the virus, inclusive if you don't have symptoms. You can be infected without symptoms, and you can go around and people can be infected because of you, but you don't have symptoms. It's tricky. That's the big problem with this illness. It figure out a way to camouflage and go around and be creating trouble everywhere without being detected. That's why it's important to do that test on time. For example, my kids were near a teacher who has COVID-19. Immediately they knew about it. The test of the teacher was available. They communicated us to be in quarantine because we didn't know. Happily, we didn't have any problem with this, but the teacher didn't know. The teacher was suspecting that she has this COVID-19. She took the exam, and next day after she was with my kids, it happens that the test was positive. So we didn't know it. It's what is. That's why it is one of the reasons why it is so dangerous. So how does COVID-19 spreads? It's from person to person, just talking. These little gotículas of saliva can be airborne for a while. So we can be contaminated also surfaces and objects that in which we find these particles, these drops, respiratory drops, mouth, nose, or eyes of close people or inhaled to the lungs. So that's why we don't want to touch our eyes or mouth, because the virus could be in your hands, and we can, when we touch our nose or eyes or mouth, the virus can go inside of our bodies. It is unlikely to be contaminated over long distances. The question is, okay, can the drops be on the floors? That's why it's recommended when you arrive to your home, change your shoes. Don't use the same shoes or disinfect your shoes, but you could be in an area in which you have the virus on the floor too, because all these drops are going to follow a flow and go on the floor, and your shoes are going to get it, and you don't want to get it to your home. So some symptoms, as I told you, sometimes people are asymptomatic. You don't have any symptom, but you can be infected and infect other people. So 2 to 14 days of incubation. You can have a fever, cough, difficult breathing, lungs and other organs can be affected, not only your lungs, but people are saying, hey, inclusive your heart, your brain, your kidneys, your liver can be affected by this because it's creating an inflammation not only in your lungs but in other parts of your body. It depends. It's case by case situation, you know. Frequent victims: advanced age people, people with lung problems, heart problems, weak immune systems, exposure to the public and infected people. For example, weak immune system, people who are in with cancer and their treatment with cancer, the immune system is not working properly. So who are going to be infected? It depends also how are you, what are you doing, how exposed are you to the virus. In some cases, very high when you are working in hospitals, in contact with people infected. It's very high, the rate of contagious if you don't protect yourself. It's high when you are in contact with people who could be infected, for example, airports of bus drivers. They could be constantly in contact with a lot of people. Medium level of infection, contact with people like in offices. And we can consider, or the government consider, that construction is in the medium level. You know, you can go and work in open areas. Try to avoid to be near other persons 6 feet. Keep a safe distance. We are going to share a video with all these recommendations. And low level of contagious if you are working from your home, for example. But as I told you, I am working from my home, but my kids went to their school and they came here with a notice, or I received a notice that a teacher was infected. Next day they came back from the school. So it's what's happening. So ARBA has created very good resources, okay, especially for the roadway construction industry. We are constantly revamping this information. We have videos. You can go to the webpage. Just Google ARBA COVID-19, and you can go to the webpage, and you are going to get videos, toolbox talk, checklists, templates, advice respiratory. Let me see if I can go there now. Yes, I can. So you can visit our ARBA webpage, and there's this area, members only, is a very good information about the state COVID-19 state by state information, how COVID-19 restriction or government decisions are affecting each state. But this safety resources area is open for everybody. Videos, toolbox talks, checklists, documents that you can use, especially for the roadway construction industry, both in English and Spanish. Let's do checklists for employers and employees, for example. So you can get one of these fact sheets or and so on. So you have very good information here that is available for everybody. You just need to visit the ARBA webpage or browse it, ARBA COVID-19, and you are going to arrive to this webpage. I want to share with you a video. We have created a video especially for the roadway construction industry, how to keep our workers safe and prevent this contamination with COVID-19.
While a highway work zone is not considered a high-risk area for infectious diseases, universal precautions can and should be made to prevent their spread between workers, supervisors, visitors, and the general public. The three primary ways in which we can protect one another from the spread of infectious diseases, such as the flu, SARS, MERS, and COVID-19, are job site screening, social distancing, and sanitation. It is everyone's job to follow these steps to make certain that we're all protected. These simple processes will go a long way in keeping you, your crew, and your family safe during an outbreak of an infectious disease. Let's talk about job site screening. Based on recommendations from the Center for Disease Control, the best way to keep distances from spreading is to keep an infected person from entering the work site. Since there's no way to work from home on a route construction site, workers who report to a job during a health pandemic or serious disease outbreak will need to enter the site. Before doing so, a person appointed by the employer should consider asking each worker the following.
In the last 14 days, have you or anyone you know been in direct contact with a person who has had a confirmed case of an infectious disease, including COVID-19? Have you or anyone in your family been in direct contact with a person who is currently being tested for a disease? Have you traveled internationally, been on a cruise, or in an airport in the last 14 days? Have you had symptoms of the disease in the last 72 hours without the use of medication? If the person answers yes to any of these questions, he or she should be sent home and not allowed to return for 2 weeks. Contact the employee's supervisor immediately and follow your company's policy for sick workers.
Next is social distancing. Social distancing is a way to restrict when and where people can gather and how close together they should work. Social distancing is meant to stop or slow down the spread of an infectious disease. Working on a roadway project doesn't often put you right next to another person, but occasionally you'll need to speak and interact with others. Following basic protocols for social distancing, keeping 6 feet apart from others, and not gathering in groups larger than 10 will significantly mitigate potential exposure. Here are some tips for you and your employer to help you continue working by practicing social distancing.
Continue morning exercise, toolbox talks, and safety meetings, but in smaller groups with individuals 6 feet apart. Use a megaphone or other amplification source if needed. Keep in-person meetings short if there is no other option, such as a phone or radio call, and maintain appropriate distancing. Take turns viewing documents or plans if there is not a digital version or hard copies for everyone. Eliminate community food options, such as lunch buffets, donuts, etc., and discourage workers from sharing food. Remove community microwaves, water dispensers, and coffee pots during the duration of the disease event. Provide water bottles and individual portion containers. Expand break spaces as much as possible within the limits of the internal traffic control plan to provide more safe distances for workers. Stagger shifts and break times to schedule fewer workers on the site at the same time to reduce exposure. Restrict access to confined and enclosed spaces like trailers and any spaces that use recycled air.
Finally, sanitation. Thorough and consistent sanitation, including regular cleaning of all shared surfaces and a strong attention to personal and group hygiene, is your last and best line of defense against an outbreak or pandemic of an infectious disease.
According to the U.S. Surgeon General, the best form of personal sanitation is regular hand washing. To the extent feasible, employers should provide hand washing stations that are separated from porta potties and break areas. Hand sanitizer is not universally effective. When washing your hands, follow these universal precautions. Turn on the water with the back of your hand or using a glove. Then, wet your hands slightly. Using soap, rinse your hands fully, front and back, for at least 20 seconds. Finally, using the back of your hands or a glove or sleeve, turn off the water. Wash your hands every time you come in contact with another person, before and after breaks, after using any tools or equipment, and immediately after entering or exiting the work zone. All shared tools and surfaces, such as steering wheels, knobs, levers, etc., need to be properly sanitized after each use. The preferred method is a cleaning fluid, not just a disinfectant wipe. Your employer should provide this for your use. Proper PPE is essential on any job. Use it. Wear it properly. If you are issued a mask for dust or pollutants, such as an N95 mask or greater, wear it and dispose of it properly after use. Bring your street clothes and a plastic or laundry bag with you, and store them in your vehicle. Before returning home from the work zone, change into your street clothes and store your work clothes in the bag. Wash if needed, or rewear your work clothes as appropriate. Be careful not to take contaminants home to your family or loved ones. Cough or sneeze into a tissue and discard the tissue in the trash. If tissues are not available, cough or sneeze into your upper sleeve or elbow, not your hands. Try to avoid touching your face.
In conclusion, these simple guidelines will go a long way to keep you, your family, your crew, and your workplace healthy and free from infectious diseases such as COVID-19. Remember the 3 key steps: job site screening, social distancing, and sanitation.
And if you feel sick, call in sick. Don't take risks that can harm someone else you know, or even someone you don't know. It's just not worth it. Stay safe and healthy at work.
Well, we have additional resources about COVID-19. As I told you, you can visit ARBA webpage. We are focusing very much in roadway construction safety with COVID-19. OSHA has a great webpage about construction safety and COVID-19. CDC is always about general public, but it has some sections about construction. And CPWR, of course, they have their own COVID-19 webpage. So you can just visit any of these organizations and you're going to find more information about how to keep your workers safe in this pandemic. So I think this is our last slide. And if you have any question, please, I am here to answer any question, Paula, or we can go with the poll too.
Well, we do have two questions. First question is this being taught just to the public sector, or is the private sector also included?
Again, can you repeat it again?
Yes, sure. Is this being taught? Is this being taught to the public sector, or is the private sector also included?
What?
Basically, who can take this course? It sounds like who can take this course.
Which course? COVID-19 or the?
Who is eligible to take this course, Robinson?
Let me think. It depends. Sorry, we are talking here about. We are talking here with the. We are working with the OSHA Hardwood grant, and it depends of the state. I need to review it. But in essential, any person in the private sector can take this course. Okay, there are some restrictions for government workers, workers from the government, depending on the state. If you are in a state with a state plan state or not, so it's something that I needed to check about it.
So but George clarified for us, Robinson. He said he asked because PERRP covers public employees in Ohio and not OSHA. So he was just curious.
Yeah, yeah. This training was provided with the OSHA Hardwood grant in general for the private sector and for workers, government workers. I think if you don't have a state plan covered by OSHA, government workers could take it. It depends, but I need to verify. If you want to organize a training with me, send me an email, please, and I can verify it for you. But these are some conditions for this training.
Okay, next question. Should construction workers out on the road be wearing masks?
Again, please, I have some difficulties.
Sure. Should construction workers out on the road be wearing masks?
No. Well, look, what is happening is that OSHA says, if you are required to use masks according to the OSHA rules, standards, you have to. Okay, that's it. There's no exceptions. They didn't create a. The only exception is maybe you can use instead of an mask with an APF of 10, you could use an APF higher. That's the exception. But in general, people are not required to use any masks in general for COVID-19 protection while you are working. But the CDCs has other recommendations, not from OSHA, but from the CDCs. So they recommend if you are working and you have you think that you want to protect yourself, you can use your own bandanas, masks. You can get your own mask. You can provide your own face covering protection system that you like. But there is a discussion about the safety of these bandanas or masks that you provide. So you are free. Workers are free to bring their own face protection according to the CDCs. But there is the situation with OSHA. Okay, but how are you going to use it? Is it these bandanas or masks are going to create another problem? Sometimes people are using some bandanas that are trapped in some machines, and they can pull all the face of the worker to the machine and have an incident because of this, so on. There is a big discussion. So, but OSHA says, well, you know, I am not requiring people to use any mask for regular working, only for the things that are in my OSHA standards. But if you want to follow the CDCs, it's something that you have to discuss with your employer, okay? Because in some cases you are working in the construction area, and sometimes people say, hey, I'm afraid if I get the COVID-19 from a coworker, I want to provide my own mask, for example. So there is a sort of gray area now, but that's the nature of the discussion. So it's not mandatory. It's not mandatory. It's optional, but you need to talk with your employer to avoid creating another problem by workers providing their own masks or bandanas or any half-face mask for COVID-19.
Okay. Next question. Will a small exposure to silica remain in a person's lungs forever?
Yes. Yes, I am sure I have it. For example, when I was young, I was working, I didn't know about all this problem. I was working in construction, and I was working in this environment. I am sure I have it. Okay, maybe I don't have symptoms. It's not so big, but yeah, I have some, I suppose I have some fibrosis in my lungs at this moment, and I cannot do anything. Sorry, the only solution is lung transplant that was successful 2 years ago, the first one. And that's the only solution, because you cannot take it from your lungs.
There are no other questions at this time.
Okay, great. So I'm going to send you, Paula, some of these, the solution for these activities and some additional information that maybe the students can find interesting for them.
Okay.
That's it. So if you can share it with them, and please.
Yep. I will add that information to the link, and I will also send you all out the post test, and please look out for the evaluation email.
Yes, please. We need them for our grantors. That's it. And thank you very much for your patience. If you want to organize one of these trainings, please send me an email or contact Paola. She can share with you my email, and we can talk, because we have some grants from OSHA to provide it for free. So, and it's especially, as you can realize, it's especially for decision makers, foremen, supervisors, engineers, but it's also useful for workers in general. But yeah, that's the information. Thank you so much, and see you in another training.
Thank you.
Be safe. Bye bye. Thank you, Paula.